Good morning, all. Today we are going to see our next topic, that is over Bezier curve and B-spline curve. So previously we have learned about the introductory part. What are the graphics? We'll just revise that. Okay. In the previous topic, we have learned what are the hardware requirements are there. Then we have seen various algorithms to 2D curves like line and circles, how circles have been drawn in the computer graphics, what are their algorithms, then the problem related to this line and circles. Then we have seen the transformation, what are the 2D transformations, what are the types of transformation, that are translation, scaling, rotation, and mirror. Then we have seen some problems over this also. So in the next unit, that is a Bezier and the B-spline. So we have to see in this topic is that this Bezier is a key Bezier for application related to, is invented by P. Bezier scientist for application related to the automobile engineering. So previously, Hermite cubic spline curves are used. So these kinds of curves using interpolate curves for the given data to draw it. So in this topic, we will learn what are the Bezier curves, what are the representative wireframe surface modeling, what are the advantages over it. Then we will see what are window and viewport flipping algorithms and problem related to that. And again, the problem related to Bezier curves. And so first of all, the basic types of curves are the explicit curves, implicit curves, and parametric curves. So these implicit curves are nothing but, suppose I am drawing this curve. Okay, so this is the initial point, and this is the end point of the curve. So it lies between. So in this implicit curves are that curves in which it should have the point. Suppose there is a point over here to create a here is point over here and here. So it should there should be a points in between these curves, and it is each point is supported by the neighboring 2 points. Okay, so these are the parameters of a implicit curve. Then the next type of basic curves is a explicit curves. So explicit curves, these are the curves for which each value of x, only a single value of y is normally computed by the function. So in this, you can see this equal to f of x, and in the case of implicit curves, it is f of x and y and z. Suppose it is a three-dimensional curve is there, then f of x, y, and z equal to 0 is there. Okay, so this f of x is nothing but the scalar functions, and in case of explicit curves, for each value of x, a single of y, normally computed by the function. Then the last is the parametric curve. So mostly in most cases, computer graphics, this parametric curve is used. In actual, practically these parametric curves are implemented in the computer graphics. So in this parametric curve, you can write down with this equation that as p of t, sometimes it is used as u also. So p of u equal to x of u or y of u, and it is varies from 0 to less than equal to u and less than equal to 1. So what are these approximate derivatives? So in this you can see this the initial position of the or initial point of the curve start from the P0 point and end with P3. So u is varies from P0 to P3, and there are actually 4 points are there. Okay, and P1 is located at u equal to 1 by third. So in this way, it the variation of this curve is in between this P1 and P2. So these 2 points are called as the control points. These 2 points are called as control points. Then another type is a interpolating. Uh, Please mute your mic. Is Ashok Pote. Hello, please mute. Okay. Suleiman, please mute your mic. Okay. Now back to our this interpolating types, in which you can see this. This is the interpolating type of curve. So it is nothing but an implicit curve type. So in which points are in between the curves, and the approximate curves are this type. So Bezier curves comes under this approximating curves. Okay. Then I will, okay. So Bezier matrix is 1, 0, 0, minus 3, 3, 0, and 3, minus 6, 3, 0, minus 1, 3, and minus 3, 1. So how this matrix will come, we'll see with the derivation. So basically it is nothing but this blending function into the original position of the curve, initial point and the end point of the curve. And this is the blending function. So let's start. Let's begin with this derivation of Bezier curve. We'll use a fresh page. Just a minute. Hermite cubic spline curves are used for drafting purpose and in the CAD software. So in today's software, spline curves are used. So what are these Bezier curves? So Bezier curves are created by P. Bezier for the application related to the automobile engineering design, and they are used approximation and smooth curves that are explained in the PPT. Then you can see this. Suppose this is the initial point of that, and the curves start and ends at this point. Suppose I will name P0 and this will be as P3, and it is supported by two control points. So it is in between two control points. Suppose it is a P1 and this will be your P2. So in this way, it is in between this and this follows these two are the control points P1 and P2, and P0 is your start point and end point is a P3, where u equal to 0 or the starting initial point, and then at this point u equal to 1. So, and this is your characteristic polygon. Okay, in between this curve lines. So suppose in the problems or the derivation, one that are the it varies from 0 to 1. That is u is a binomial relation, and n defines the degree of polynomial. So how much degree is it's u cube, it is u cube or u square. N equal to 2 is there, then u square, you have to vary it to the u square. The equation will change. And when n equal to 4 is, then u raised to 4. You have to so I think if we define the binomial function, then c n I n comma I equal to n factorial divided by I factorial in bracket n minus I factorial. So in this this c n comma I, uh, in which n is where n is the defines the degree of polynomial, whether it is cube or square. Okay, it is the degree of polynomial, and the value of I is the control point. Has I is the I characteristic the control point has. Suppose pi. Okay, then you have to vary it to 0 to 1. Then at I equal to 0, if I equal to 0 is there, that is this initial point, I equal to 0, then c in bracket n comma 0, then equal to n factorial. Suppose this is my equation number 1. Okay, now this equation 1 will become n factorial 0 factorial in bracket n factorial. So it is equal to 1. Then at if I is equal to n, that is this end point. It has number of points in between that. This is end point, this is the start point. Then c in bracket n comma n equal to n factorial divided by n factorial in bracket n minus n factorial. Again the value will come 1. Suppose this is equation number 2 and this is equation number 3. Then what Bezier curve defines is that, just a moment. Okay. What Bezier curve defines that P of u equal to Pi in bracket c in bracket n comma I ui. So this is nothing but the blending function 1 minus u n raised to I. Okay, now suppose this is the equation number 4. Now due to this equation, put these values, then by expanding this we'll get p0, that is we are respect to 0 less than equal to u less than equal to 1 when we vary this equation. Then p0 cn c in bracket n comma 0 u raised to 0, then 1 minus u n minus 0. So here we have taken that I value is equal to 0. Then again p1, now we are taking I value equal to 1. Okay, the c n comma 1 u raised to 1 and 1 minus u n minus 1. Now so on, we can increase up to Pn, where I value now becomes n, and c in bracket n comma n, u raised to n, and 1 minus u n minus 1, where we vary this to 0 is equal to 1. Now substituting this value in equation number 2 and 3, we'll get P of u equal to P0 in bracket 1 minus u raised to n plus P1 in bracket C in bracket n comma 1 u, so 1 minus u n minus 1 plus so on up to Pn u raised to n. So I will write in this equation number 5. So in exam problems that they ask over this Bezier curve as well as this derivation. If we consider the same curve as we drawn over here, this has some error. Okay, I will redraw that curve again. That is the initial point and that. Okay, so this is P0, P1, P2, and this is here P2. So here n is equal to 3. Okay, is polynomial is 3. So Pn, we can write down Pn equal to P3. Pn equal to P3. Thus the value of n will be 3. Thus the value of n will be equal to 3. Now we can write out the equation in this way: C3 comma I equal to 3 factorial divided by I. The previously we used I equal to 0 and I equal to 1, and then after up to I equal to n. So now we have to take equal to 3. So this first I factorial, then 3 minus yes I factorial. So after solving this, you'll get 6 by I in bracket 3 minus I factorial. So now we have to take I equal to 0. When I equal to 0 is there, so 3 and 0, we have to keep this n value same. So then 0 factorial 3 minus 0 factorial, you will get 1. Then again I will be equal to 1. Then 3 comma 1, you will get 6 by 1, 3 minus 1 factorial, you will get 3 value. Then similar 3 to I equal to 3. So 6 2 factorial 3 minus 2 factorial, you will get 3. And then last 3 and 3, you will get 6 3 factorial 3 minus 3 factorial, you will get 1. Now putting these values in the equation, this answer, this 1 3 and 1 in that equation number 5, then you will get P of u equal to P0 in bracket 1 minus u cube plus, now this 3, instead of that 3 c in bracket 3 and comma 1, you have to take this value 3 P1 u 1 minus u square plus p square, this value 3 p square, sorry, p2 u square in 1 minus u plus p3 u cube. Okay, so they can up to n equal to 3. Okay, then you can also take this all this degree of into 1, that is p of u equal to u cube. So converting this equation and into matrices form, u cube, u square, u and 1, and the matrix will become minus 1, 3, minus 3 and 1. Just solving this, expanding this equation, you will get this value minus 6, 3 and 0. So minus 3, 3, 0, 0 and 1, 0, 0, 0. And that is the position of the point P0, P1, P2 and P3. So this will be your U value. This will be your matrix MB, and this will be your P value. This matrix will be. So you can write the final equation as P of U equal to this U, capital U, this one, into MB into the position P. Okay, so this will be a final equation. Okay, so in this way you have to derive, if we like in examination, derive the Bezier curve expression. They will ask you. You have to solve it. After this, you have to draw the curve, and then you have to solve it up by considering that the degree of a polynomial n equal to 3. Okay, so I have a simple problem over this. So this will be a, I will add a page. Okay, now in the problem given in the examination, they will ask you plot the Bezier curve points having point. You can simultaneously solve with me by just take a notebook, and you can with me also, so that you can also get the hands-on practice over this. Endpoints P0, 1, 3. Okay, so that this is starting point is given, and ending point is given P3, 7, and the control points given. The other control points are P1, 5 and 6, P1, 5 and 6, and P2, 6 and 0 is given in the problem, and you have to plot these values for the values of U equal to 0, then 0 0.1, 0 0.2, up to 1. Up to 1, you have to vary this. If the characteristic polygon is drawn in sequence. So they will ask you in sequence means P0, then P1, then P2, and P3. Suppose this is your 0, P0, that is given is 1 and 3. P0 is 1 and 3. So this is your initial position, and it will change up to this value. And this will be your y u equal to 0, and this end point u equal to 1. And you have to find out the points wherein this u equal to 0, then u equal to 0.2, 3, 6, 4, 5, 6, up to 1. You have to vary it. Okay, and it is controlled by these 2 points. That is, suppose this is a P1 or P1, and this will be, suppose it is a P2. So it is between these 2 points. Okay, now how to solve this? Then in some books they will use matrix. They will use that the fifth equation, that is P of u equal to P0 1 minus u bracket q plus 3. In this way they have solved in some books, but I will suggest you to solve by using the matrix. So that will be much easier to solve. Okay, so now in this case n given n is equal to 3, and points given P0 equal to, write down first that point 1 and 3, this 1 and 3, then P1 equal to this P1 is 5 and 6, 5 and 6, then again P2 is given, P2 equal to 6 and 0, and last the end point given is 7 and 2. 7 and 2 is given. Okay, then in some books they will use this equation P of u equal to P0 1 minus q plus 3 P1 u 1 minus u square plus 3, as it is a n equal to 3 is there. So we are starting with the power of 3. So 3 P2 u square 1 minus u plus P3 u cube. So these parametric elements are used, and you have to find out the value of x and y. So instead of this, you can use the matrix, that we have find out that equal to matrix formula. First you have to find out the value for the x, and then you have to find out the value for y. Okay, so px of u equal to, I write down that sixth equation we have find out from the derivation, u cube, u square, u and 1. Okay, and then the matrix mb matrix is -1, then 3, -3, and 1, and 3 and 0. -3, 3, 0, 0, and 1, 0, 0, 0. Now you have to write the point P. Okay, so for the P points, what are the P0, P1, P2, P3 points? You have to write down here. For that, first I will write down P0 point, that is 1 and 3, 1 and then P1 point 5 and 6, 5 and 6, then P2 point 6 and 0, 6 and 0, then P3 point 7 and 2. Okay, so this equation is nothing but P of u equal to capital U MB into P. So this is the positions of the points, and these are the matrix of Bezier, and this is is the U is the degree of polynomial. Okay. Now I will. Okay. This software has some issue. Okay. Then multiply by using the same matrix we have solved in the previous transformation also. That is a row into column multiplication you have to do for x and for y. Okay. Then how to do that? At first you have to multiply this row into column. I will rewrite that again. U cube, U cube, U square, U and 1. Suppose we are doing for P of U, X. Then the matrix is -1, 3, 3, -3, 1, 3, -6, 3 and 0. Then -3, 3, 0, 0, and 1, 0, 0, 0. Okay, this is the matrix and the positions given of the points 1, 3, 5 and 6, 6 and 0, 7 and 2. Now how to multiply this? That is column multiplication. So -1 into this 1, -1 into this 1, you will get equation -1. Okay, I will increase this width of this column. Okay. -1. Okay, so 3 into 5, so it will become 15 plus 15. Then -3 into this 6. Okay, so we are going to row the column multiplication. So -3 into 6 minus 18. Okay, then 1 into 7, so plus 7, plus 7. Okay, so in this way you will get, after solving this, we will solve it again. Okay, then again this will be the value for x. Whatever will be the answer, this will be the value of x. Then for the value of y, -1 into 3, so it will become -3. Okay, then 3 into this 6, 3 into this 6, 18 plus 18. Then -3 into 0, 0, 1 into 2 plus 2. Okay, that these are whatever it is, it will be for y. Then next row, again same columns. Okay, next row, what is this column multiplication? So again 3 into 1, 3 into 1 is 3. Then -6 into 5 is -30. Then 3 into 6, 18 plus 18, and 0 into 0. This will be value for x. Then 3 into 3, 9. Then -6 into 6, 36, -36. Then 3 into 0, 0, 0. Okay, so this will be value for y. Then again -3 into, now this row, and again -3 into 1, -3, 3 into 5, 15, 15, 0, 0. So it will not be. Then again this row in second column, -3 into 3, 9, -9, 3 into 6 plus 18, 0, 0. Okay. Then last row, and again these two column multiplication, 1 into 1, 1, finish. Then this 3, it will become 3. Now after solving this, you will get u cube, u square, u and 1, and this matrix you will find after you get 3, then 17, next -9 and -27, then 12 and 9 and 1 and 3. Now to get the p of x equation, you have to multiply this row into this, you will get the equation for p of x, px of u, and for p of y by of u, you have to multiply this row. We will do that. Like, yeah, you will get 3u cube minus 9u square plus 2u plus 1 plus 1. So you will get this equation for x, and for y, here y, you will get 17u cube minus 27, then 9u plus 3. So these two equations you will get. So now we have to vary the points, that is from 0, u equal to 0, then u equal to 0.1, then u equal to 0.2, 0.3, 0.4, in this way. And in examination also, just make a table. First I will rewrite this two equations, because after creating some issue, p of x 3u cube minus 9u square plus 12u plus 1. Okay, so this is the equation for x, equation for y will be 17u cube. I will be writing this because it's creating some issue. 27u square plus 9u plus 3 plus 3. So no, it is showing issue. Okay, then this will be equation. Now in examination, if this type of question will be asked, then draw a table, just simple table in this way. Right here u, right here px u and py u. Okay, okay. Now you have to vary from 0, then 0 0.1, 0.2, 0.3, 0.4, and so on up to 1, up to 1. So make this in this way, up to 1. Then first if we have, so in the first, for 0, use u equal to 0 in this equation, and you will get the answer 1. Okay, then u equal to 0 in the second equation for y, you will get answer 3. Okay, solving it. Okay, I will not show that. Okay, then after 0.1 it will give you the answer 2.11 and 3.64. Then if we use u equal to 0.2, then it will give you this answer. Okay, 0.6, then 3.8. So in this way, you have to solve up to this one, and I will give one example for a homework purpose. You can run that, and we will again solve it tomorrow. So write down this problem for homework. You can write down it. Plot the behavior curve. Similar kind of problem. Behavior curve having endpoints. Again, the endpoints is given t0. Okay, and you have to draw that curve also. So because it is for 10 marks, so 2 marks to drawing that initial condition of the behavior curve. So p0, 0, and 0, and this is the initial point, and the end point is p3, p3, 7, and 0. 7 and 0 is the end point, and the control point given, I will write down that p1 equal to 7 and 0, p2 equal 7 and 6. So these are the control These are the control points. These are the control points. Now they have asked you that plot plot the values for u equal to again same 0, then 0.1 up to 1, if it is the characteristics of polygon is in sequence, is drawn in sequence, that is p0 in sequence, that is from p0, p1, then p2 and p3. So in examination also you have to draw that this Bezier curve by using this x and y, and in this way you have to draw it appropriately, and then you have to start solving this problem in the similar way I have taught in the previous problem. So this is your homework. We are going to solve this again in this tomorrow lecture, tomorrow or the day after, on Thursday, and we'll see some different varieties of problems in this also, and we saw one cubic spline problem also in this. Okay, so that's all for today. So any questions regarding this, or any uh, uh, any questions or any notes you required for the first unit? I will upload it on this. Okay. Hello. I will first download your attendance. Okay. Any questions regarding today's session? Whether I am going very far or that
Sir, which book we have to use for CAD CAM, sir? Cause we don't have books.
okay.
Is
I will
any
I
online
will
book is available?
I will share that. I think if it is available online, but I prefer that means using the soft copy will not help very much, as it is by the hard copy will help while solving the problems and all. So you can use the CAD CAM principles and applications by PM Rao, that covers entire syllabus of your CAD CAM subject. That is much better book is there, and any other notes apart from this book, extra notes, some problem, because these problems are not there in the in that book. So I will upload the scanned copies of this. Okay, it is of CAD CAM and CAD CAM and automation by, I think, author author is not there. I have that notes are there. I will upload by scanning it, which the book doesn't have. Okay, you
Okay,
can
sir.
read. It covers entire syllabus of CAD CAM. Even it has and you can for the other subject you have, that is manufacturing process, no? For that turning programming is there. Okay, manual part programming. For that purpose, all this book is very good. It has given varieties of problems and all. Okay, so that's all for today. We'll continue some more problems, so Bezier curves and B spline. Okay. Thank you for listening.